The kids of today use Ethernet as a matter of course. Today we are talking about Ethernet-APL. It's about the physical layer that will revolutionize the field of process plants. But it's not really a revolution, it's more of an evolution because Ethernet-APL is the mix of two technologies that our users appreciate. On the one hand, there is Ethernet. We all use Ethernet. We simply connect our Ethernet devices, our laptop, our smartphone, our TV to the network, and it finds its way to the internet, to a server. Yeah, and on the other hand, we have the two-wire line. The two-wire cable, which is valued because it is extremely robust, because it is stable in terms of installation technology, because it meets the harsh requirements in the field of a process plant. And Ethernet-APL combines these two types of things into a physical layer that now brings Ethernet all the way to the device. Ethernet-APL is specifically designed to carry any Ethernet-based protocol into the plant. It provides explosion protection, it supplies power to the field device, and it is based on a cable that our users know and appreciate, which is the two-wire cable. We have actually, and Pepperl+Fuchs has also been one of the pioneers in the development of Ethernet-APL to this point. We have really broken physical boundaries to make these three features executable for Ethernet. And that is exactly the end result of Ethernet-APL, a standardized physical connection that is a network. Ethernet brings a network to the field that allows us to automate many of the steps that need to be done with instrumentation on a daily basis. A simple example: I plug in an Ethernet device somewhere, and the first thing it does is log on to its network. In the past, that was not possible with instrumentation. Now, with Ethernet-APL, any field device anywhere in a process plant can do the same thing. That is, it connects, logs into its switch, and connects to the network first. And when the asset management system now automatically detects this field device, its configuration is automatically saved. But Ethernet can do a few other things. It knows about something like neighborhood detection. The alphabet soup for that is called LLDP, for Link Layer Discovery Protocol. And a switch or field device that masters this protocol knows exactly who its right and left neighbors are. So a server can now query all switches in the network and determine who is your right and left neighbor and what is connected to your ports 1 through 8. And so the server application can now automatically reconcile and document how the plant is wired. And these are Ethernet technologies that we all take for granted today, that work for us in the background, that the technical experts have mastered, but a technology that simplifies the way we manage field device technology in the area of the process plant quite considerably. For users, this means that they can set up a data backup for each field device. I can now download the configuration from the field device and save it to a server as quickly as I receive the radar image. I have never experienced such success as Ethernet-APL in my career in process automation. There is hardly anyone I talk to today who doesn't immediately say, "I'd like to try that in a plant." Ethernet-APL has the potential to establish itself in many process plants and therefore finally initiate the digital turnaround in the field of process plants.